Okay guys, this is your homework help video for your FRQs for the week of 1/27 through 2/4. This is our first one. This is on page 82 of your FRQ books. We're going to be doing number 4, option A. So here we go. Change my pen color here. I don't like the green. All right, the height of a tree at time t is given in a twice differentiable function h, where h of t is measured in meters and t is measured in years. Selected values of h of t are given in the table above. Use the data in the table to estimate h prime of 6, and using correct units, interpret the meaning of h prime of 6 in the context of the problem. Okay, so this is an instantaneous rate of change, and we are estimating it, which means that we're going to be using the average rate of change to estimate the instantaneous rate of change. Okay, so when you're doing this, you want to pick the 2 points that are closest to the value that you're trying to find the instantaneous rate of change at. So this is a x value. So the 2 points that are closest to x equals 6 would be here, right? Here's x equals 5, or t equals 5 and t equals 7. So we're going to use these 2 data points, all right? So h prime of 6, the instantaneous rate of change of this function at t equals 6, can be approximately said to be equal to the average rate of change between h of 7 and h of 5. Now h of 7 is 11, h of 5 is 6, so that's going to be 5 over 2. And so there's our first piece of the answer there. So we've accomplished the first thing they've asked. However, they do want us to use the correct units and interpret the meaning. Now, you got to remember, when we talked about this in the last chapter, whenever they ask you to interpret, they are looking for 3 things. Okay, first of all, you need to include the context, the story problem that they're even addressing here. So we need to be talking about the height of a tree and whatnot. We also need to address the input units. In other words, what are the units of the number that we are plugging in here? And also we need to address the output units. Which is what this is over here. So what are the units of our final answer? So let's go ahead and start here. So we know that the context is about the height of a tree over time, right? The 6 is a t value, so that's years. And then the output, well, these are on the top is meters, right? The 11 and 6 are meter values. The bottom is years. And so the 5 over 2 is meters per year. And it's a positive number. So we have an increasing amount. So what the interpretation of this problem is that the instantaneous rate of change of the height of this tree at the year t equals 6 is approximately 5 over 2 meters per year. So that's what we would need to say. So the instantaneous rate of change, I'm going to abbreviate here, but never do that on a real FRQ because they don't know what rock means, but I don't have much space. So the instantaneous rate of change of the tree's height at t equals 6 years is 5 over 2 meters per year. Now I've got all 3 of those things that I told you need to have in there. Okay? we have the context. What does the number represent? It's the instantaneous rate of change of the height. What are the input units? T equals 6 years. What are the output units? 5/2 meters per year. So when you do an interpretation, you always include all 3 of those components. Okay. Moving on to our next one. Okay, now we're looking at the next FRQ, page 126. We're going to be doing the first problem there. So we're doing number 2A. And just so you guys know, anytime an FRQ is numbers 1 or 2, and sometimes 3, it's usually a calculator problem. So we're going to be using our calculator on this one. All right, so let's see here. For a particle moving on the x-axis, time is always greater than or equal to 0. The velocity of the particle is given by this function here. And the particle is at position 2 when time equals 4. Now, the only thing that we really care about here is the velocity. We're not going to use the position stuff on this. That's for other parts of this FRQ. We're going to really be making some pretty good use of this thing here. All right, so at time t equals 4, is the particle speeding up or slowing down? Now, in case you guys forgot, you have velocity being positive or negative. You have acceleration being positive or negative. When both velocity and acceleration are positive, your particle is speeding up. Or when they're both negative, they're both speeding up. The particle is speeding up. But whenever the acceleration and velocity have opposite signs, they're working against each other. So your speed would be decreasing at that point. Okay? So to answer this question, we need to look at velocity, and we also need to look at acceleration. All right? So let's go ahead and begin the process here. So first of all, we need to find the velocity at t equals 4. So using our calculator, we're going to go ahead and plug it into our function for velocity. But we also need to find the acceleration. So to find acceleration, you find the derivative of velocity. So v prime is what we'll call acceleration. So the derivative of v is the 1 here is going to go away. The 2 is going to stay because it's a constant multiple. And then sine becomes cosine. And we leave the inside alone, but now we will multiply the entire thing by the derivative of the inside. The derivative of the inside, if you multiply 2 to the front, the 2's cancel and you're just left with t. So you end up with an extra t in the front after you do the chain rule there. So there is our acceleration function. And so the acceleration at 4, we need to find that also. So that's going to be 2 times t, which is 4, cosine of, once again, 4 squared over 2. Okay? Now just to make things a little bit easier, I'm going to change 4 squared over 2 into a simplified version. 4 squared is 16, and 16 over 2 is 8, so I'm just going to put 8 there. That'll be a little bit easier to type into our calculator. I'm also going to change this 4 times 2 out here to be 8 as well. And basically we just need to find out, does this come out to be positive or negative or what? So that's where our calculator is going to be coming in handy for us. All right. So here we go. Let's plug in 1 plus 2 sine of 8. Get a positive number. Now we'll do the other one. 8 cosine of 8. And that's a negative. And so since my acceleration and velocity are opposite signs, we would say that it's slowing down at that point. Now you can't just so you guys know, you can't just write, oh, well, it's slowing down and hope that you picked the right one. Okay? This problem doesn't ask for an explanation, but they would need to see your math. Okay? Now, if they ask for an explanation, you would have to say something like, oh, well, since the velocities is positive and the acceleration is negative, the particle is slowing down. It doesn't ask us to explain, so I think it's okay just to include the math here. But just simply writing slowing down, they will not give you any credit for that, I guarantee you. Okay, so let's go ahead and move on to our next one then. All right, so this is the one on page 168. I hope you guys are trying these before you look at the videos, because I would certainly hope you're able to do this one. This is one that we're doing in class right now quite a bit, so I would hope that you guys would be able to do this one without having to watch the video, but I'm including it just in case you weren't understanding why you may have gotten it wrong. All right, so we're looking at a twice differentiable function of f and g. And they've given us various values of f and g in the table there above. It's asking us to find the x-coordinate. That's important. Pay attention to that. The x-coordinate of each relative minimum. Now, you guys know a relative minimum is a y value, but they want to know what's the x value that goes with that relative minimum. And they're asking for it on the interval of -2 to 3, which basically spans the entire table. So they just want to find where the relative minima. And then secondly, this is pretty important, they do say justify your answer. Okay? And oh, another detail, they want us to pay attention to f. So we don't care about g. I'm just going to scribble that out. We're just looking at f. Okay? As you guys know, relative extrema happen at critical values. And so critical values are where the derivative equals 0. So my derivative equals 0 here and here. Now, you have a relative minimum when your graph goes from negative to positive slope at that point, thus resulting in a minimum value. Which of these zeros goes from negative to positive, left to right there? And as you can see, it's this one. We go from negative to positive, whereas over here with the other one, it goes from negative to negative. It didn't change signs, so that's not even an extrema at all. But this one here is the one that went from negative to positive, and that happens when x equals 1. And so our answer is x equals 1, and to explain that, I'll show you what you write. So the answer would be x equals 1 since f prime changes from negative to positive at that point. Okay? So, pretty straightforward, pretty simple. Let's go ahead and move on to yet another question. And the last. All right, for this last one, we're on page 190 of our blue books. And we are going to be doing option B. So we have a function, ln of x over x. X has to be greater than 0. And they also give us the derivative of that function, which is silly, in my opinion. They should make the students figure that out, but they thought they'd be nice, I guess. I don't know. There's really no reason you guys couldn't have figured that out. But let's go ahead and take a look at part B. Find the x-coordinate of the critical point of f. Determine whether this point is a relative min or max or neither, and then justify your answer. So we have 3 things to do. We need to find the x-coordinate of the critical point. Okay? That would suggest there's probably only one. Next, we need to determine whether this point is a relative min or a max. So that would be the second thing we need to do. And then the third thing that we need to do is we need to justify our answer, and that's going to be taking on the form as the same thing that we did in the last one, actually. All right, so Critical points. That happens whenever the derivative is 0 or undefined. Okay? Now, I don't have to find the derivative of this function because they gave it to me already. So where is this function 0 and where is it undefined? Well, we've talked about that a derivative of a fraction expression is going to equal 0 when the top of that fraction equals 0. And we've also talked about how the derivative of that function is undefined or does not exist when the denominator of the function equals 0. Now for this one over here, that's only going to happen if x equals 0. We're not even going to consider that. And the reason is because x has to be greater than 0. It can't equal 0. Would have been a game changer possibly if they'd have put an equal here and the function was different, but since we're not including 0, we're going to ignore that one. We're going to look at f prime of x is equal to 0 though. So the first thing I'm going to do is going to add ln on both sides, which will mean that ln of x equals 1. ln of x equals 1. Well, what we're going to do is I'm going to exponentiate both sides, like so. And what happens is this and this cancel, so we end up with x being equal to e. So this is a critical value. So we've answered question 1 there. What is the critical value? Now we need to decide, is this a relative min or a relative max? And to do that, we're going to do our number line test. So E, you guys got to know what E is. E is approximately, I'll do squigglies, it's approximately 2.71. Okay? So we want to pick some numbers that are less than E and greater than E. And this is not a calculator question because this number's 6. So we don't want to use our calculator to evaluate this. So part of the trick of this one is you want to make sure you're picking numbers that you're actually going to be able to solve. In other words, what can you plug in here so that you can actually figure it out by hand and without the aid of a calculator? You know, so for instance, give me a number less than 2.71 that you could plug in. Well, for instance, some of you guys might say 0, but you got to remember we can't use 0 in this problem. It's not allowed. The next most convenient number would be 1. And it turns out that 1 is a number you can actually plug in. What is ln of 1? That would be 0. And plug in 1 on the bottom, you get 1. So you have 1 minus 0 over 1, which is 1. So we have a positive slope on this side over here. Okay? Now, next we need to figure out what's going on the other side. And this is where it gets kind of tricky for us to figure out what we should plug in. Okay? And this is something you probably wouldn't have thought of, but hey, this is what the videos are for, and take these as opportunities to open your minds to new things. You might be tempted to plug in 2. Now technically there would be nothing wrong with that. The problem is, do you even know what ln of 2 is? You don't, because I highly doubt you do. I don't know it off the top of my head either. So what else can we plug in here that's bigger than e? Well, anything you plug in that has an e to a power and it's going to be really easy. So let me show you the little trick I'm going to do here. It doesn't seem fair, it doesn't seem right, but hey, we're learning math, so now you'll know after this. Something bigger than e that would be really nice to plug in over there would be e squared. I'll show you why. Because if you were to plug in e squared, ln of e squared, these cancel and you're just left with 2. That's a really easy thing to figure the answer out to. So 1 take away 2 is negative 2, or negative 1, I'm sorry, back up there. Negative 1. And on the bottom we have e squared squared. Now it doesn't matter, if we're squaring things, it's always going to be positive. It's e to the 4th, but it doesn't really matter. So we have a negative over a positive, which means this is negative. So we have a slope that's going from positive to negative, which makes that critical value of e a relative max. So now we've answered the other question. And the explanation would be because we're going from a positive slope to a negative slope. So I'll show you guys how to officially write your answer. But you do need to show that work. But here's how it would be. You'd say x equals e is a relative max since f prime goes from positive to negative at that point. And that takes care of it. So that's the end of our FRQs for this week, and we'll see you guys later.